So we've used rulers in the past. And if you notice, here we've got three rulers, ruler A, ruler B, ruler C. And we need to discuss what makes a ruler a good ruler and what makes a ruler a bad ruler. Or better said, what makes a ruler accurate versus one that is not as accurate. So kind of common sense tells you that ruler A is not the best ruler, right? You've got two markings, you've got 0 centimeters and 10 centimeters, and that's it. While ruler C, if you notice, has all of those hash marks there. So why is ruler C a better ruler than ruler A? Why is it more accurate? Well, it's because when we are actually measuring using ruler C, we will actually have more digits that we can read. Okay? It's going to give us a more accurate reading than ruler A will, and this is why. If you look at the valid measurements here, when you're making a valid measurement, if you notice, this has 3 and 2. That's considered a valid measurement. 3 and 2 centimeters. Invalid measurements include 2.5, 3.00, 3.33, and 3 1/4. Okay? If you look at ruler B, notice now ruler B not only has that 3 digit that all of them agree on, but then they all have a 10th place measurement for centimeters as well. Okay, so those are valid measurements. If you then look at the next ruler, it not only has the ones place and the 10th place that it's being able to read, but also the 100th place. So notice the valid measurements for ruler C are much more accurate than for valid measurements for ruler A. And here's why. Here's why the invalid measurements that you see on the right-hand side are invalid measurements. The rule is as follows. In a valid measurement, you can only record one estimated digit. Okay? So if you notice, for the valid measurements for ruler A, you have 3 and 2 are your estimated digits. And the reason why is because the only digits you are certain of using ruler A is the 0 and the 10. I know that my measurement's going to be somewhere between 0 and 10, so I can only estimate one digit. So this person estimated that it was 3 centimeters, this person estimated that it was 2. 2.5 would be incorrect. It's an invalid measurement because the 2 and the 5 are being estimated, and you can only have one estimated digit. In ruler B, notice I have markings for 0 centimeters, 1, 2, 3, etc., all the way to 10. So my ones place I am certain of. Notice for all of these valid measurements, they all agree on the 3. There's no question that I have passed the 3 mark. So that is not my estimated digit. I am certain of that digit. It's the next digit, the 10th place now, because I don't have a marking for the 10th place. That is what we are estimating. So this person estimated that this goes to 0.2. That measurement right there is 0.2. This person estimated that it was 0.1 and then 0.3. So that is allowed. Those are valid measurements because they have one estimated digit. If you look at ruler C, the same thing applies. Notice I have markings for the ones place. Those are the big hash marks that you see. And then I also have markings for the 10th place. So each tiny little line that you see is at 0.1 centimeters, which means if I have this measurement here, notice this is going to be 3, this is 3.1, and this is going to be 3.2. So what this is saying is I am certain I've passed the 3 mark, so that is a certain digit. This is also saying that I am certain that I've passed this right here. It's kind of hard to see, okay? But that's 0.2, so this is saying I am certain I've passed 0.2. So those digits are not up for debate. If you put 3.1, you would be wrong because that is not an estimated digit. You don't have the freedom to estimate that digit. Instead, the 3 and the 2, those are certain because I have markings for them. Where you get some liberty is with the 100th place. So you can estimate the 1, the 2, or the 0. You can say, that looks about 0.01, or that looks about 0.02, or that looks about 0.00. Okay? So if you look at these, now it should be clear why ruler C is a better ruler than ruler A. It's because ruler C allows you to be a lot more accurate. You have 2 certain digits and you have 1 estimated digit. And that's because of all of the lines that you have for ruler C. In ruler A, you don't have all those lines, and so as a result, you can only estimate because you can only estimate one digit, the only measurement you can read is 3 centimeters or 2 centimeters. So in a valid measurement, you record one estimated digit. In a valid measurement, as we noted, the estimated digit is going to be the last digit in the measurement. Okay, so I've got some practice for you, so you're going to pause this video, and then I'm going to go into discussing significant figures and how we can use this concept in discussing significant figures. So starting now, you're going to be hearing the word significant figures a lot. And what significant figures tells you is simply how accurate your measurement is. Okay, so the more accurate a measurement is, the more significant figures a measurement will have. So it simply tells us how accurate a measurement is. So what I'm going to do is I'm going to teach you really quickly how to count sig figs, and then we're going to go back and look at the measurements we just did to really understand what significant figures mean. So to count significant figures, I've got a map of the United States here. And just as a review, this is my Pacific Ocean, and this is my Atlantic Ocean. Okay? So if a decimal is present, and remember, a decimal is simply that dot. If you see that dot anywhere in a number, what you're going to do is you're going to count from left to right. You're going to go from the leftmost number that you can see, and you're going to count until you stop counting. If there is no decimal, meaning you don't see that point, then you're going to count from right to left. You're going to start with the rightmost number that you see, and then you're going to start counting. There is only one additional rule you need to keep in mind when determining sig figs, and then you've got it completely covered. The only rule that you have to remember, other than Pacific and Atlantic, present and absent, is the fact that you cannot start counting on a 0. And that'll make a lot more sense in just one sec. That's the only other rule you need to keep in mind. Okay, so let's look at a bunch of examples to make sure we understand this. 609. If I were to say how many significant figures does this value have, notice there is no decimal here, which means the decimal is absent, so I'm going to count from right to left. And remember, you start counting on your rightmost number. Well, the rightmost number I have right here, farthest to the right, is this 9 here. So I've got 1, and I can start counting because it's a 9, it's not a 0. I have 1, 2, 3 sig figs. Okay? And remember, the more sig figs you have, the more accurate your measurement is. If you look at example 2, I have a decimal present. There is a decimal place. So I'm going to be counting from left to right. So my leftmost number that I have here is this 0 here. It's not that you start at the decimal, it's that you look for your leftmost number. The leftmost number that I have here is the 0 right here. So I'm going to start counting, but remember, you can't start counting on a 0. So I'm going to move from left to right, but I can't count this 0 because I can't start on a 0. I can't count this 0 because I can't start on a 0. So the first number that is significant in that number is the 2, so I have 1 sig fig here. Okay, let's look at the next example, 0.680. I have a decimal place present. You see the decimal right there. So I'm going to take the leftmost number, which is a 0, and I'm going to start counting. 0 is my leftmost number. However, I can't start counting on a 0, so I can't count that 0. So my first significant digit is the 6, then I've got the 8, and then I've got the 0. So I have 3 sig figs. So keep in mind, once you start counting, you absolutely can count a 0. It's just you can't start counting on a 0. Okay? Let's look at example 4. 6.0 times 10 to the second. If you notice, we just talked about scientific notation in a previous lesson. If you see a number in scientific notation, do not take it out of scientific notation. Just look at the coefficient, which is the 6.0, and determine the number of significant figures in 6.0, and that will be the number of significant figures in your value. You can ignore the 10 to the second. Okay? So looking at this, a decimal is present. I've got a decimal, which means I'm going to be counting from left to right. Well, my leftmost number that I have here is the 6. So I'm going to count the 6, and since I've started counting, I can also count the 0. So I've got 2 significant figures here. Okay, let's look at the next example, 6,100. Okay, notice there is no decimal present here. It is absent, so I'm going to be counting from right to left. Okay, I look at my rightmost number that I have, which is a 0. Remember, you can't start counting on a 0, so that can't count as a significant figure. That can't count as a significant figure. So the first number I can count is a 1 and the 6, so I've got 2 sig figs. Okay. If we look at the last example, I give you 780. Now notice I gave you a point here, and that is really important to note. Because I put a decimal, instead of counting from right to left, which I would have done if it were absent, I'm now going to count from left to right. So since I'm counting from left to right, my leftmost number that I have, the farthest to the left I have, is this 7. So I'm going to start counting, because I can start counting on a 7. I've got 1, 2, 3 sig figs. Now, if I had given you just 780 without the point, the decimal would be absent. I would start counting from right to left. My rightmost number is a 0. I can't start counting on a 0, so that would have been 2 sig figs. Okay, so here I gave you 780 point, that gives you 3 sig figs, and 780 without a decimal is 2 sig figs. Now, I'm going to say something that is extremely controversial right now. 780 point is a different number than 780, and here's why. When I give you 780, right, remember you have to have one estimated digit. So when I'm talking about sig figs, if I say 780 has 2 sig figs, what that tells me is that the 7 is certain and my 8 is my estimated digit. Because remember, if I have 2 sig figs, one of those digits, the last digit is going to be my estimated digit. You always have to have one estimated digit. So what this is telling me is that I am certain that it's going to be, let's say, for example, I'm measuring in milliliters. Okay? I am certain that my measurement is 700 mils. I know it's 700. However, the 8 is estimated. So when I tell you I have 780 mils, and I write it like 780 without the decimal point, what I'm telling you is I have 700 mils and then some extra. And I think it's about 80, okay, because that 8 is my estimated digit. When instead I give you 780 point, what I'm telling you is I know I have 780 mils, and it's the 0 here that is my estimated digit. So I know I have 780, and then I'm going to estimate this digit. It could have been 781, 782, but I know I have 780. Meanwhile, with 780 without the decimal point, I'm estimating that 80 mils. So these are 2 very different volumes. They could be, right? Because for 780 without the decimal, I'm estimating the tens place, while for 780 point, I'm only estimating the ones place. So 780 mils could really be 770 mils, and I estimated loosely, right? Meanwhile, 780 point, it has to be 780, but it could be 781, 782. So there's a lot less variety in measurements in the volume I get when I'm talking about 780 point versus 780. So you can only measure a quantity based on what your tool allows you to do. So if you have a very accurate tool, maybe you can measure to 3 sig figs or 4 sig figs, right? Remember, you have to have one estimated digit. But if you have a horrible ruler like ruler A that we saw before, you might only be able to have 1 sig fig. So what I want us to do right now, we're going to practice taking measurements or taking numbers and rounding them to the correct number of significant figures. So for example, 7a, I give you 86, and I ask you to round to just 1 sig fig. So I need to round this number so it only has 1 sig fig. Well, right now it has 2. I've got the 8 and the 6, which means I'm going to want to get rid of this 6. And I'm going to just want to keep this 1 digit. So what I'm going to do is I'm going to round this 8. Now, do I need to round it down, meaning keep it as an 8, or round it up to a 9? Well, looking at the digit right behind it, the 6 is larger than 5, which means the 8 is going to round up. So that's going to round to 9. Now, a lot of students make the error of putting 9 and then calling it a day and moving on to the next problem. You can't round 86 to 9, though. They're 2 totally different numbers. If you gave me $86 and I gave you $9 back, you'd be very angry. Remember, you have to hold the ones place that you just got rid of So I'm going to make that 90. Now keep in mind, because I don't have a decimal, this I would be counting from right to left. You can't start counting on a 0, so the 9 is the only significant digit, and therefore I only have one sig fig. Okay, let's look at the next example, 0.0345. So remember, if I'm counting sig figs, because I have a decimal present, okay, these first, I'm going to count from left to right. The first 2 zeros that you see are not significant because you can't start counting on a 0. So the 3 is my first significant digit, and that's the only one I'm going to want to keep because I'm asking you to round to just one sig fig. So I look at the digit right behind the 3. It is a 4. So will the 3 round up or stay a 3? It's going to stay the same because 4 is less than 5. So it would be 0.03 for one sig fig. If I look at the next question, 1.83 currently, that has 3 significant figures. Counting left to right, I can start counting on the 1, so 1, 2, 3. So the only digit I want to keep one sig fig is that one right there. So I'm going to look at the digit behind it. It's an 8. So 1.83, the 1 will round up to a 2, and I've got one sig fig now. Okay. For the last one, I've got 327. So right now, I have 3 significant figures, 7, 2, and 3. I only want one significant figure, so I'm going to just keep the 3. I need to decide if I need to round that up or keep it the same. Well, the 2 will not round the 3 up, so the 3 will stay the same. Remember, please don't just write it as a 3, though. It was 327. So I need to hold those 2 places. So this is going to be 300. Okay? Let's look at some more examples. It says round the numbers to 3 sig figs, then round them to 2. So I'm going to first round this to 3 sig figs. So right now, 1823 has 4 sig figs. So I'm going to want to keep the 1, the 8, and the 2. That's it. That'll give me 3 sig figs. So I look, does the 3 round the 2 up? No, it does not. So I'm going to keep it as 182. Keep in mind, I have 1,823. That does not round to 182. That would be incorrect. I need to make sure to hold that place with a 0. And because this 0 is not significant, because I'm going to be counting from right to left, I only have 3 sig figs here. If I wanted to then round this number to 2 sig figs, I'm going to only want to keep the 1 and the 8. So I look, does the 2 round the 8 up? No, it does not. So I'm going to keep the 1 and the 8. Those are my 2 significant digits. And then, or figures, same thing. And then I'm going to want to hold the place with 2 zeros. So it stays 1,800 instead of just becoming 18. If I look at the next problem, 0.62347, I want to round to 3 sig figs. Remember, this first 0 is not significant. So it's just the 6, the 2, and the 3 that I want to keep. Does the 4 round the 3 up? No, it does not because it's less than 5. So I'm going to keep it as 0.623. Let's look at the next one. I want to round to 2 sig figs. So I just want to keep the 6 and the 2. The 3 does not round the 2 up, so it would just be 0.62. Okay, let's look at the next one. 7,508. If I want to round this to 3 sig figs, I want to keep the 7, the 5, and the 0. Okay, so if I want to keep the 7, the 5, and the 0, the 8, does it round the 0 up? Yes, it does. So I'm going to write this as 7, 5, 1, because the 0 rounds up to a 1, and then I need to hold the place to keep it in the thousands, 0. So it's 7,510. I'm going to make this really challenging just for a second. What if instead of 7,508, what if I had given you 7,504 and I asked you to have 3 sig figs? Okay. If you look at that, you would say, okay, I'm going to keep the 7, the 5, and the 0. The 4 does not round the 0 up, so this would be 7,500. Here's the issue. That's not 3 sig figs. That's only 2. Because I don't have a decimal, which means I'm going to count from right to left. So the zeros would not be significant, so it would just be the 7 and the 5. To which you say, well, how could I give that 3 sig figs? And the answer is, I could write that in scientific notation. If I were to take 7,504 and put that into scientific notation, remember, I'm going to move my decimal 3 places, 1, 2, 3. So this value will become 7.504 times 10 to the third. That's still 4 sig figs right here. But what I can do now is say, okay, 7, 5, and 0 are my sig figs I want to keep. The 4 doesn't round it up, so now this would become 7.50 times 10 to the third. And keep in mind, because I now have a decimal present, I'm going to be counting from left to right. The 7, the 5, and the 0 are my 3 sig figs. So while when you write 7,500 in standard notation, it can only have 2 sig figs. When you write it in scientific notation, it can have 3. So do be careful, because sometimes you're not going to be able to write a number in standard notation because you won't be able to have the correct number of significant figures. Okay? All right, so for this one, I want 2 sig figs. Okay, so I'm going to keep the 7 and the 5, and then I'm going to have 2 zeros after it to hold the place. All right, 124.5, I want 3 sig figs, so I'm going to keep the 1, the 2, and the 4. Those are my 3 sig figs. The 5 is going to round the 4 up, so I get 125, and that is 3 sig figs. If I want 2 sig figs, I want to keep the 1 and the 2. The 4 does not round the 2 up because it's less than 5, which means my value is going to be 120. So the last concept I have to go over is, okay, when do we use sig figs and when do we not? You will use significant figures whenever you are measuring. Okay? Whenever I'm using a ruler or a graduated cylinder, I'm recording time, right? Because significant figures tells you how accurate the tool that you're using to measure is. That being said, there are times when you will ignore sig figs, and that's when you have exact numbers. So there are really 2 situations where you have an exact number. The first one is when you are comparing 2 different values. So if you look at the first example that I gave you here, I tell you that 1 liter is 1,000 mils. So I'm giving you a relationship. I'm comparing 2 different units. So when I give you this kind of relationship where I'm telling you 1 liter equals 1,000 mils, right? I'm giving you a specific relationship. You're not measuring that, and therefore that value is going to be exact. The other time that it's going to be exact is when you are counting. So if I say, hey, I've got 4 stools in my kitchen, there's no debate about how accurate that is. They're either 4 stools or they're not. So when I give you a relationship, like something equals something, that's going to be exact. And when you're counting, that's going to be exact. If you look at the next example, I give you 3.4 grams. That was clearly measured, right? And therefore, I would have to count its significant figures. And then the next lesson, we're going to actually learn how, when you're doing math, how we need to treat significant figures.